Alright, in this lesson we are going to be learning about logarithms as inverses. And we've talked a little bit about inverse functions, and in our next lesson we're going to be graphing logs as inverse functions. So our learning targets for right now is I can write and evaluate logarithmic expressions, and then again later, and mostly in the next lesson, is I can graph logarithmic functions. So let's look here. We're talking about earthquakes to start with. So the magnitude of an earthquake is a measure of how much energy is released at its source. And we use the Richter scale for that one. This is an exponential measure of earthquake magnitude. An earthquake of magnitude 5 releases about 30 times as much energy as an earthquake of magnitude of 4. So it's not just a linear scale here, we're looking at exponential, right? So multiplying. So you can see in this example, if the magnitude increases by 1, so we add 1 to the magnitude, we multiply the energy released by 30, and that's what makes it exponential. Okay, so we're going to look at some seismology. In 1995, an earthquake in Mexico registered 8.0 on the Richter scale. In 2001, an earthquake with a magnitude of 6.8 shook Washington state. So now we're comparing the amounts of energies. So we first want to write a ratio. Okay, so I know that we're talking with a base of 30 here. So 30 to the 8.0, which is where I had my first earthquake, right? And then e to the 6.8 was my second earthquake. So I first write my ratio, and I can simplify. The e's can go away because there's one in the numerator and one in the denominator, and we're multiplying. And e over e is the same thing as 1. So now I use my division property of exponents, right? So if I have the same base, which in this example is 30, and two different exponents, I subtract my exponents. So I have 30 to the 1.2, and then I use my calculator and I actually put that in. So then my final answer is the earthquake in Mexico released about 59 times as much energy as the earthquake in Washington. And that's a huge difference because it's times and it's not just an addition problem here. So now here's a problem that I want you to try using the same steps that we just did. In 1997, so we had an earthquake in Alabama that registered 4.9 on the Richter scale. And then in 1999, we had one in California that registered 7.0. We're going to compare the energy. So go ahead and do that right now. So those exponents that we used in the Richter scale are called logarithms or logs. Okay, so here is something, this definition you're going to want in your notes because we're going to use it a lot here. So the logarithm to the base b of a positive number is defined as followed. So you've seen this a lot, right? Y equals b to the x. So I take my base and I raise it to an exponent. So sometimes we don't know what that exponent is, and that's really hard to find out. So we're going to use the inverse, which is called a log, and find that out. So I still have my log base b, there's where my base goes, y equals x. So just reading logs, just so we can use our math vocabulary correctly, we're going to read this as log base b of y. That's just how we read logs. So here's another example. So now that we know exponential functions and we know logarithmic functions, we can go back and forth between the two depending on what we have and what we need. So I can take this exponential function, right, 25 equals 5 squared, and rewrite it in logarithmic form. So I use my little handy dandy cheat sheet here. So I know that y equals b to the x. Then I know log base b of y equals x. So then I substitute the different values in where they go, and I have now an exponential function and a logarithmic function. And they are the same thing, just written as inverses of each other. Okay, so now here's a couple for you to do. I want you to do these, write these equations in logarithmic form. So we can also go backwards, right? In that last example, we were given an exponential equation and asked to write the log form. We can be given a log equation and be asked to write the exponential form. So here's what we're doing right here. We're evaluating log base 8 of 16. So first I'm going to write it, and then I can convert it to exponential form and kind of simplify. I try to want to write everything in base 2 because base 2 is very simple and we can multiply 2 very quickly. So I know that 16 is the same thing as 2 to the 4th, and I know that 8 is the same thing as 2 cubed, and then I have that x out there still because I'm missing an x. So now that I have this written out, right, I can use the power property of exponents. When I have a base with an exponent to another exponent, I multiply those exponents together. So since my bases are the same, I can just take my exponents and set them equal to each other and solve for x. So in this case, my log base 8 of 16 is 4/3. So you'll notice that we didn't use the calculator at all in this one, and we don't want to very often unless we have a common log. So our common logarithm is a logarithm that uses base 10. Okay? If you see something written as a base 10, you know it's the common log, but also if you see this example here, just log of y, without a base written, we know that it is a 10. And this is the most common one that you'll see, and this is also what you'll see on your calculator. So if you see something that has a different base, we'll talk about that, about how you can still use your calculator and change the base to be able to evaluate different logarithms. So here I want you to evaluate each logarithm using the steps that we just did on the previous page to get me a result from this. So we can also use common logarithms to measure acidity, right? Which is our concentration of hydrogen ions. So the pH equals a negative log of those H+, those hydrogen ions, where H+ is that hydrogen ion. Okay, so the pH of lemon juice is 2.3, while the pH of milk is 6.6. We're supposed to find the concentration of hydrogen ions in each substance, and then figure out which substance is more acidic. So I know that pH equals negative log of the hydrogen ions. So I'm told the pH here equals log of that, so then I can kind of simplify and rewrite it as an exponential equation and solve. Same thing for milk. Write out what we know and what we have and simplify and turn it into an exponential function and solve. So I know that the hydrogen concentration of lemon juice is 5 times 10 to the negative third, and the hydrogen concentration of milk is 2.5 times 10 to the negative 7. So lemon juice has a higher concentration, right? If I was to write these out, lemon juice has my higher concentration, so it is more acidic. Okay, so now here's your homework. This is also written in your calendar, so make sure you check that. This will be working on next week and the rest of this week. So let's go back and just double check our learning targets. So we definitely talked about this one. I can write and evaluate logarithmic expressions. We can also go back and forth between logarithmic and exponential. We're really going to hit this learning target in our next lesson.